Okay, welcome to Math 31, Notes 8.2. In this section, we're going to learn about perimeter and the concept of circumference. Okay, we're going to start with the idea of a polygon. And a polygon is a closed shape where each of the sides is a line segment. So you can see I've just joined line segments like this. And if you make a closed shape like this without the lines, the segments can't cross each other, but if you go around like that, you get what's called a polygon. Now, we classify polygons in a number of ways. This one has 6 sides, and that qualifies it as a hexagon. Okay, the idea of circumference, or excuse me, perimeter in this case, is it's the sum of all the side lengths. So you add that length, that length, that length, and just work your way all the way around, adding all the lengths until you've gone all the way around. And so ultimately, perimeter is the distance around an object. Okay, so let's start with a few formulas. When you have a rectangle, you can take a shortcut. You've got two of the lengths, one on the presumably top and the other on the bottom, and then the other two widths are the same. So instead of going length plus width plus length plus width, you just do two lengths and two widths. In the case of a square or any other regular polygon where the side lengths are all the same, you just take the number of sides times the side length. A square has 4 sides, so you go 4 times the side length. You'll see I have an example of that one later. And in general, if you have a regular polygon, you might think of a stop sign, or you might think of a honeycomb shape where you got a regular hexagon and all the side lengths on the hexagon are the same length. You just take the number of sides times the length of the side, and that's this last one here. So number of sides times the length of the side. Okay, so here's a couple of those shapes. Rectangle, think of it in this way. You got a width and a matching width, a length and a matching length. So you could take a shortcut. Instead of going length plus width plus length plus width, you just take, for the perimeter, just take two lengths, 2 times the length plus 2 times the width. In the case of a square, you could say s plus s plus s plus s, but that would be the same as the number of sides, 4 sides, times the length, 4s. On a parallelogram, if you got a side length of a, the other side across from it's also length a, and then same thing in the other direction. So its perimeter is 2 of the a lengths plus 2 of the b lengths. Okay, our first example here is not a regular polygon. It doesn't have a formula. You can see that the side lengths are just a bunch of different sizes. And it's a 4-sided shape. We would call that a quadrilateral. But all we care about here is how far would it be if you went all the way around. So I like to start in top left corner and work my way around clockwise when I do this. So I'm going to say 9 plus the next side if you go around is 10 plus 13, and then finally you're back around once you add that 6 in. So you get 38 meters as your perimeter. Okay. On this rectangle, part B here, we have a 24.5 on the right side, and that would be the same as the one across from it. And likewise, in the other direction, you know that has to be 8.5 inches. So if you want to write it all the way out, it'd look like this. You could go 2 of each length, but I'm just going to write it all the way out. 8.5 plus 24.5 plus another 8.5 plus 24.5. And once you've worked your way all the way around, just add them all up and you get a perimeter of 66 inches. Okay. Next, we're going to look at this square, and the square is an example of a regular polygon where all the sides are the same. So there's 4 sides, they're all 8, so the kind of the long way to get this done is just to add all the 8s. And that gives 32 centimeters. But if you want to take the shortcut formula, you just say 4 sides, each of them 8, gives 32 inches total, or centimeters total. Okay, this parallelogram, you need to know that the sides across from each other are the same. So 23 inches there, and up here 42 inches. So it's just a matter of adding those up, and you could take the shortcut if you wanted to. I'm just going to do the basic way of doing it. So 42 plus 23 plus 42 plus another 23, and that would be 130 inches of perimeter. That would be the same answer if you went 2 times the 42 plus 2 times the 23. Okay, the next shape we're going to look at here is a regular octagon. And as soon as you see that word regular, you know that once I've told you one side length, I've told you them all. There are 8 sides, and they're all 5.2 long, which turns out to be 41.6 inches of perimeter. Okay, this next shape on part F here is probably the most challenging one on here because you are actually missing some side lengths. You don't know that side length there. And the other thing that you're missing is the base down there. You don't know how long that is. So you have to actually do some work to figure that out. So let me show you how this works here. I know that this is 8 feet, and it's part of, if I slide this down here, it's part of the rectangle that I'll highlight here. It's part of this rectangle, so you have to visualize that. And because it's part of that, I know that this is 8 across. Now, some of the same logic goes in on the other side. If this is 14, well, I can slide that 14 down here, and I know that that length is also 14. So if I'm going all the way across this object, it's 8 plus 9 plus 14, which gives 31 feet across the bottom. Now I'm going to turn my attention vertically to figure out the other missing one, and it's actually harder to do. I know that this is 20. It's labeled as 20, and if I slide it over, I know that that whole height is 20, and the upper half of it, or the upper portion of it, is 13. So that makes the bottom section 7. So now I'm going to shorten this line here, or let me delete that and draw another one. I know this bottom has to be 7. Okay, so now what I'm going to do is take that 7, and I'm going to slide it across there, and that part is 7. I'll slide it over further. That part's 7, and the whole height is 16, which makes the upper part 9. So I'm going to write that. That's 9. And now you can take that 9 and visually slide it across over there. And so you know that it's 9 on that missing section. So now we just add up all the way around, and I'm going to start in this corner and work clockwise around this thing. So the perimeter of this thing is 8 plus 13 plus 2 9s in a row would get me all the way. What I've traveled so far is here, 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 and here. Okay, then I keep going. There's a 14 and a 16 as I work my way around this object. And then I'm going across the bottom, 31 plus 20. And that turns out to be, when you add those all up, 120 feet of perimeter. So you have to do some fancy footwork to get the missing information out of that thing. Okay, the last section on this is the idea of circumference. And it's grouped together with perimeter because the concepts are the same. You're trying to measure the distance around the object. But here the object is always a circle, and hence the name circumference. You can see kind of the start of the word is talking about a circle. Now, one version of the formula uses the diameter, and the other uses the radius. So you obviously have to have that in mind, and I'm going to give you a little device of how to remember this here. Okay. The word diameter and the word radius. A radius is from the center to the outside, so that's the radius. And that is a grand total of 6 letters long. And if you go all the way across the circle, that's the diameter. And that's 8 letters long, so it's obvious that the word diameter is longer than the word radius, 8 letters versus 6 letters. And the physical object, or the geometric object that it indicates, diameters are twice as big as radii. I wish it was 4 letters and 8 letters, then it would be a really good analogy, but you just have to remember diameter is longer than the radius. And let me show you the relationship between the two. There is one radius there and another one on the other side, so the diameter is exactly twice as long as the radius, or the other way around, the radius is half as long as the diameter. Now, the two formulas, you pick it depending on which one you're given. This is a radius on this first problem here. It only goes from the center to the outside. So with that in mind, I'm going to use the second version of the formula, 2 pi r. And I know the value of, well, the 2 is part of the formula. I would normally put 3.14 in here, but it says give exact answers. It doesn't want an estimate. So you're going to use the Greek letter pi when it asks for an exact answer. And the radius is 6. So here you just say 2 times 6 would be 12, 12 times pi, and you leave it with the pi as part of your answer. You do that when it wants exact answers. As soon as you put either 3.14 or 22 over 7, you're estimating the answer. And that's not what is asked for in this problem. Now this next one here, they give us a diameter of 32. You can see that that stretches all the way across the circle through the center. So we're going to use the other formula, pi times diameter. We're using the one that has diameter in it. And it's equal to pi times 32. And it is customary to write the 32 in front. So 32 pi, and then the units are miles. So if you were estimating, you would have used 3.14 for that pi and then actually done the multiplication. And that's what we're going to be doing on this problem, because it wants us to estimate using the value of 3.14 for pi. So here we go. Circumference is 2 times pi times the radius. That's the version of the formula you want to use when they give you the radius. It's the one with r in it. And we're going to estimate pi as 3.14. And don't forget the radius is 4.2. And you multiply all three of those numbers to get your answer. 26.376. The little dot above the equal sign means I'm rounding or estimating or approximating. And right here is where that happened. Pi is actually not 3.14. It's an irrational number that keeps on going, 3.1415926, and so on. Okay, they want us to use a different estimate of pi this time, the number 22 over 7. And this is a fraction. Pi is not a fraction, so it can't be right. But it's a pretty good estimate, so if you don't care how accurate your answer is, this will work just fine. Okay, so they give us a diameter of 14, and we're going to say circumference is pi times diameter. That's the formula you want to use when they give you the diameter. And we're going to be estimating using 3.14 as the value of pi. And, oh, nope, that's wrong. And I forgot my setup here is completely wrong. So give me a second to just erase all this because it's totally wrong. All right, here we go. Pi, we're estimating it as 22 over 7. And we're multiplying that by the diameter of 14. So if you take 22 times 14, That gives you 308. And divide that by 7, and you get 44. Okay, so I'm going to put a little dot above the equal sign because this right here is not accurate. It's close to pi, but not pi. And so I carry that all the way through. It's very close to 44 centimeters. The units here of length are centimeters. Okay, so that does it for notes 8.2.